In this video, we're going to set up a triple integral where our region is bounded by a plane in the first octant. So you can think of the first octant being we want x is greater than or equal to 0, y is greater than or equal to 0, z is greater than or equal to 0. So that's what we mean by the first octant. Again, it's always nice to draw pictures, so and in drawing that picture, we're really going to need to find some intersections. We are once again going to do the same thing we did before, which is find our intersections, do some top minus bottom stuff, or at least what's it between, and then smush. So let's find our intersections. And we're basically asking, where does this intersect the x-axis, the y-axis, and the z-axis? Or where does it intersect the xy plane, the yz plane, and the xz plane? And I think the picture is going to be the best way to do this here. What I note is that this plane is going to pass through some points on the plane. If I set y and z equal to 0, I see that 8 has to equal, or x has to equal 8. If I set x and z equal to 0, I see that y has to equal 4. And if I set x and y equal to 0, I see that z has to equal 2. So these are some points on my plane. Since planes are very straight line typey things, that's a very technical term, what we see is that the intersections are just going to be, oh, that was bad. They're just going to be the straight lines between those points. So this is the plane that or kind of the section that we're going to be looking at, is the volume bounded by this. So how we consider these intersections is really going to depend on how we want to, what direction we want to start in. We've been typically starting with z because that's kind of the most natural to do, but we could just as easily start with maybe x. And one reason I might choose x is that x is, it's between y and, or x, it would be really easy to solve this for x. I could rewrite this as x minus, x equals 8 minus 2y minus 4z. And if we're looking at what does x have to be between, I'm going to write top minus bottom, but top minus bottom is not going to be the best thing to think of here. What's x between? Well, it has to be bigger than or equal to 0 because we're in the first octant. And okay, so that's our inequality. Oh, and it has to be less than this plane, this thing that we just solved for. So we have our first inequality. So bottom was 0 because we're in the first octant. Top was what's our plane when we solve for x. So we got that. And now we are going to smush onto the x, or onto the yz plane. Which is a little different. So let's look at what we have there. I'll just draw it exactly like we have there. So we have this line going here, which is basically what happens when you smush this region just onto the yz plane. And when we have this, you could think of this as horizontal or vertical. Just, for the sake of doing some weird stuff, we're going to think of this as horizontal strips here because it's going to be slightly easier, as you'll see. But first of all, what is this line? Well, this is the line. Y equals, has a y-intercept of 2, and it has, well, actually has a z-intercept of 2. because remember this is our z-axis, this is our y-axis, is a z-intercept of 2, and we are going down at a slope of -1/2. So it's z minus 1/2 y, or honestly, maybe we'll just leave it there. I could solve this for y. It would be what 2 or 4 minus 2z equals y. And you could use either one of those. I think this one, we'll go ahead and raise this. This one might be a little easier to visualize. So we'll go ahead and use that. So again, what are we between? Our z-coordinate is bounded between this line, 2 minus 1/2 y, and the y-axis. So we're going to have 0 is less than or equal to z is less than or equal to 2 minus 1/2 y. And now we're going to smush again onto the y-axis. What's that picture going to look like? Well, when we smush it, we're just on the y-axis now, so we'll draw a little y-axis there. When we smush it onto there, all that we have is stuff going from 0 to 4. So we see that 0 is less than or equal to y is less than or equal to 4. So when I go and set up my triple integral, we're once again going to start from kind of the first thing we did and then work our way from the inside out. So my integrand was x squared z. And I decided to start integrating this in respect to x. Honestly, not a great idea. Probably wanted to start in respect to y. We could have if we had just thought of this slightly differently. But we didn't. We made mistakes, and that's okay. Sometimes we make mistakes. So you'd have x squared z going from 0 to 8 minus 2y minus 4z. Actually, we just chose all the worst options. We waited until the very end to integrate in respect to y. So, I'll leave it up to you to do this better. Maybe that'll be the problem. Then, next, we looked at our z-coordinate. What was z going between? Well, z is going between 2 minus 1/2 y, or sorry, 0 and 2 minus 1/2 y. And then last but not least, we looked at what's our y-coordinate going between. It's going between 0 and 4. So there we go. We've set up a triple integral to evaluate the integral of this function over the region bounded by the plane in the first octant.